Today, in this video, we will see numerical on member subjected to uniaxial force system. Numerical is a piece of steel 1 meter long and 30 mm by 30 mm in cross section, 30 mm by 30 mm in cross section is carrying a tensile force of 120 kilonewton in axial direction. Calculate change in volume. Take modulus of elasticity E is equal to 2 into 10 raised to 5 Newton per mm square and Poisson's ratio is equal to 0.29. Length of piece L is equal to 1 meter or 1000 mm. Cross-sectional area, this P load acting on this cross-sectional area denoted as A, (30 mm by 30 mm), 30 into 30, 900 mm square. Poisson's ratio mu is equal to 0.29. And modulus of elasticity E is equal to 2 into 10 raised to 5 Newton per mm square. Calculate change in volume to find change in volume denoted as delta V. Solution. Volumetric strain EV is equal to change in volume to the original volume, and therefore change in volume is volumetric strain multiplied by original volume, and volumetric strain is change in length to the original length multiplied by 1 minus 2 mu. Mu is Poisson's ratio into this V. This is change in volume, and this change in length to the original length is strain. Strain in L direction multiplied by 1 minus 2 mu into V. Stress is load upon area, and E, modulus of elasticity, is stress upon strain. Therefore, this E, strain, is stress upon Young's modulus. Therefore, I write here strain is stress upon Young's modulus multiplied by 1 minus 2 mu into V. This is change in volume. And we have to calculate change in volume, and formula for the change in volume is stress upon Young's modulus multiplied by 1 minus 2 into Poisson's ratio multiplied by total volume. So in numerical we have Young's modulus Poisson's ratio and original volume also see in diagram. We have to calculate stress. Stress is load upon area C. Axial load 120 kilonewton, 120 into 10 raised to 3, 120 kilonewton, and 120 into 10 raised to 3 is in Newton, divided by area 900 mm square. That means this stress value comes in 120 into 10 raised to 3 Newton per mm square. 133.34. Stress is 133.34 Newton per mm square. For this axial load 120 kilonewton, stress is 133.34 Newton per mm square. And change in volume formula, stress upon modulus of elasticity or Young's modulus into 1 minus 2 into Poisson's ratio into total volume. Change in volume is equal to stress upon modulus of elasticity into 1 minus 2 mu into V. Into V. Stress is 133.33. 133. E is 2 into 10 raised to 5 multiplied by 1 minus 2 into Poisson's ratio is 0.29 multiplied by volume 1000 into 30 into 30. That means original volume of that piece of steel is 1000 into 30 into 30, L into B into T. One thousand into 30 into 30. Change in volume is 252 mm cube. Unit of volume is mm cube. For that, piece of steel 1 meter long, change of volume is 252 mm cube. And original volume of this bar is 1000 into 30 into 30 mm cube. That means original volume of this bar is 9 lakh mm cube and change in volume is 252 mm cube. Thank you very much.